Hey everyone, today I want to show you something pretty cool. We'll see how to set up our own Starknet node using Juno. This video is not just going to be a demo, we are actually going to set up an infrastructure which you can use for the real projects that you make on Starknet. We are working with Juno today, which is a Starknet full node client written in Go and is built by Nethermind. Lots of apps in the Starknet ecosystem actually use Juno at the moment. So it's proven to work very well in production. What I like the approach that we are taking in this video is that we'll use the official Juno docs as our guide, and you'll see how I read through the technical documentation and turn it into a working setup, which is something you'll do all the time as a developer. So let's get started. Let me tell you what we are doing today and why is it useful for you. We are setting up a Starknet node right on your local machine. This means that you get direct access to the Starknet blockchain without depending on a third-party service. Your node will have its own copy of the blockchain data and can serve requests independently. The cool part here is that we'll use Juno's Snapshot feature for really fast syncing. So instead of waiting 8 to 12 hours or maybe more to sync from the beginning of the Starknet blockchain, we'll download a recent snapshot and the node will be up and running in about 15 to 20 minutes. You will learn how to use Juno's snapshot feature, which networks you can choose from, how to check their sizes, and how to download the snapshots in the correct manner. You'll understand the difference between the Starknet's 3 networks and when to use each one. Plus, you'll know what normal behavior looks like when your node is syncing and how to test it with API calls. Let's talk about the prerequisites. When it comes to hardware requirements, we need a Mac or a Linux system, or Windows is also fine, but we need to have WSL installed in that. You'll need about 15 GB of free space. As right now we are dealing only with testnet, this much space is enough. Then we'll require 4 GB RAM minimum, but 8 GB is better. And we also need a decent internet connection since we'll be downloading few GB of data for the snapshots. So the whole thing takes about 15 to 20 minutes or so. And when it comes to software requirements, we should have Docker to run Juno, JQ to make JSON look nice, and gawk for the snapshot size commands that we'll be using from the Juno docs, and an Ethereum WebSocket endpoint from any RPC provider. So, all right, let's jump into the terminal and check if I have all the system requirements ready to go. Okay, so in the terminal, I need to first check if I have Docker installed on the system already. So yes, we do have Docker. Then I need to check if I have JQ installed already. I assume yes, we have that as well. Then I should check if I have gawk available with me. Yes, we have that as well. Then I need to export a Ethereum Sepolia WebSocket connection because we are dealing with testnet right now. So I have one WebSocket connection URL with me handy. So I'll just try to export that. Export ETH node. And this is the WebSocket URL. Let me just export that. And perfect. Everything looks good. And now let's jump into the official docs and see which networks are available to us. So this is what the official Juno documentation looks like. And the next step would be for us to check the database snapshots and the different types of networks that we have available to download. And what we'll be doing is, you can see that we have the similar definition that Juno database helps you to reduce the network syncing time, and only the blocks created after the snapshot will be synced when you run the node. And fresh snapshots are automatically updated once a week and are available under these links. As you can see, we have 3 different types of networks present here: Mainnet, Sepolia, and Sepolia-Integration. I'll be telling you the difference of these 3 networks and who should use which network. But first we'll check the sizes of different database snapshots that we have here. So let me just open up my terminal side by side. And what we'll be doing is copying this curl command to first get the size of the mainnet snapshot. So it's about 207 GBs. And then we'll copy the next command to get the size of Sepolia testnet. So we can see it's about 35.22 GB, which is 36 GBs. And the third command is for the snapshot size for Sepolia-Integration. I assume it will be the lowest. Yes. So it's almost 8 GB. Now let me explain what is the difference between each of these networks. So as you can see, we have Mainnet. So this network is where real transaction are happening with actual value, and it's the biggest snapshot at around 207 GBs approximately. And you would use this version of snapshot for production applications. Sepolia is the next network that we have, which is the main test net that most end users interact with. It's great for testing dApps and wallets, and has a medium sized snapshot around 35 GB, and its most popular choice for general development work. And the third one, which we saw here, was Sepolia-Integration, and it is a developer focused testnet specifically designed for people who are working on Node and sequencer development. It has the smallest snapshot at around 8 GB, and it's perfect for tutorials and testing like what we are doing today. So we'll use Sepolia-Integration since it's the smallest and downloads the fastest. But remember, the process is exactly the same for these two other networks. Okay, so as we go down a bit in the documentation, we can see the first thing that we need to do is create a directory on. So let me just clear this first. Then we can paste this and snapshot. And I'll also create a subdirectory, which is, let me name it Sepolia, even though we'll be downloading the Sepolia-Integration snapshot. Just for convenience, I'm typing it Sepolia. So here we go, it has been created, and ZSTD is already installed for us. The next thing that we have to do, and this is what I was talking about, we need to create a subfolder just for clarity, and then we need to copy this curl command, but this is for mainnet and we need it for Sepolia-Integration. So let me just copy this. Then we need to type curl -s -l, then paste the link for Sepolia-Integration, and then we need to copy this part, and okay, and remember that we named the folder as Sepolia. So let me do that as well and press enter. Okay, so as you can see that this is pretty neat, and the snapshot is being downloaded right now, and it downloads, decompresses and extracts in one go. And I'll speed up this process since it takes a couple of minutes. So as we can see that the download of the snapshot has been completed, and the next step for us would be to go to the running Juno page on the documentation, and we'll go through the Docker container setup because that is pretty easy and quick. And the Docker setup works for every system, to be honest, because the way Docker is built. So let me follow this documentation. So the first thing that we have to do is pull the image. Now this might take a couple of minutes. So this has been completed, and the next part would be to run the container, but with the snapshot which we just downloaded. So instead of Juno mainnet, we should be doing Juno Sepolia, because that's the way we named our directories. So I'll just copy the command which I have already present with me. It is similar to this. I'll explain you the command. So basically, as you can see, the name is Juno, snapshot, Sepolia, the name of the folder which we had. It will be running on port 6060, and the host port would be 0.0.0.0, and the network is Sepolia-Integration, as I said. And this is the environment variable which we exported at the very beginning, the ETH node. which is a WebSocket URL. And as you can see, this has been running. So great, we can see it's running. The docs mention that using Docker logs, we can see what is happening in the background. So let us just check that. So if I do Docker logs -f and type Juno and press enter. So look at this. The node started with block 2.2 million something and instead of 0, and that's our snapshot working. So as you can see, it is working correctly. And the next part would be for us to actually make a JSON RPC request to this Juno node, which is running. So let me open up another terminal here and put it here. Let me just fix this. So the next step for us would be to actually make a JSON RPC request on the Juno node, which is running locally on our machine. So as you can see, this is how we make a JSON RPC request. And with this curl command, I'll be using curl command. You can see we can get the Juno version. So let me just paste and put it like this. And as you can see, everything is working perfectly. You can see it's running and we get the latest Juno version. It's synced with the network. And to check if it is already synced, because we have already cross-checked it is synced, but just from a curl command, if we can get the block Starknet block hash number, that would give us a verification that everything worked fine. And as you can see, the block number right now is 2283084, which means our snapshot is also working. So great. And we are done. We just set up the working Starknet node using Juno, and we use the official documentation to do that. You have your own Starknet node running locally now with full API access, and you can just try with the mainnet version or the regular Sepolia version as well. Just change the snapshot URL and the network parameter and repeat the same process which we did in this video. And yeah, you're good to go.